So I'm really glad that you decided to watch this video because I'm going to give you a lot of clues that you're going to need for the quiz today. So don't tell your neighbor if they're not watching the video because this is just for you. If you can, get a sheet of paper and you can actually write what I write on the sheet of paper, and because you're so good at watching this video, I'll let you use it on the quiz, but shh, keep it a secret. So the first thing we're going to do is we're going to talk about the difference between temperature and thermal energy. And on your quiz, instead of thermal energy, they're going to use the word heat. So just remember that thermal energy and heat are the same thing. So if they ask you on the quiz something similar to this, like you have a cup of water that, let's say, is 74 degrees in temperature, and you have a swimming pool, and let's say it is 74 degrees in temperature, well, which one is going to have the more heat? Which one's going to have the more heat energy? They both have the same temperature, but the swimming pool is going to have more heat energy. Okay, so you're going to remember that the larger object, the object that has more particles in it, is going to have more heat energy or more thermal energy. Okay, so then the next question, or the next couple of questions, it's going to ask you about temperature scales. And if you hear some scratching in the distance, that's just me writing on my bamboo board. And there's actually three main types of temperature scales. There's the Kelvin, there's the Celsius, and there's the Fahrenheit. Now all of them are very similar, okay? But the Kelvin is the one that's used in physical science. And on the Kelvin scale, you're going to hit 0 K. And I'm just going to put a line through that 0 so it looks like a 0 and not an OK. On the Kelvin scale, the boiling point of water is 373, which is actually 273 more than the Celsius scale. And water freezes at 273. Okay, so let's look at the Celsius scale. Now, 0 Kelvin on the Celsius scale is negative 273. On the Celsius scale, water freezes at 0 degrees, and on the Celsius scale, water boils at 100 degrees. Okay, so in comparison, you have the Kelvin has the 373 and the 0 K on it. The Celsius scale has the 100 and the negative, and the 0 where water freezes. See, this kind of carries over to here. Now on the Fahrenheit scale, this down here is like negative 470 is absolute 0 on the Fahrenheit scale. Water freezes at 32 degrees and water boils at 212 degrees. So that's how you can identify the Fahrenheit scale. Okay? We're going to remember down here that this is absolute 0. And that's on the Kelvin scale. Okay, and absolute 0 is when no more matter moves. Matter no longer moves, and this is an L, sorry. Matter no longer moves at absolute 0. Okay, so then the next thing we're going to learn about is heat transfer, and I'm going to clear the screen. You're also going to need to know that heat always transfers from hot to cold. So it's always going to go from an area of hot to an area of cold. Okay, so a good example of this, that's an arrow. Apologize for that. Here, let me erase that. Try that again. So it always goes from hot to cold. So if you have something like grapes in a cooler, okay, Okay, so in a cooler, the heat from the grapes is going to go into the ice cube, and it's going to cause the ice to melt. So it always transfers from hot to cold. So the food makes the ice hot. Therefore, because it's losing its heat to the ice, it's going to get cold naturally, and it's going to keep transferring until you get the same temperature. So now we're going to talk about heat transfers. There's actually 3 types of heat transfer. Okay, the heat transfers are conduction, radiation, and convection. Okay, so what I like to remember on these 3 is that conduction has basically all the letters of touch. It's got the T, the C, the U, the O. So that's heat transfer by touch. So anything that has direct contact, and you're going to see these words used on your quiz, that's going to be conduction. So anything where objects are touching. And in conduction, the particles don't move. Meaning that if I have like a poker, like a fire poker, which kind of looks like that, and I put it in a fire, the heat is going to transfer from one particle to the next particle to the next to the next to the next until your hand burns hot right here. So it's just going to climb up that poker. Okay, then we have radiation, and this is heat transfer by the sun's rays or fire. So you're going to have radiant heat coming off of a fire. Anything where a sun's rays or the fire's rays are coming off of it, that's radiation. And then convection, the way I remember convection is where this arrow right here, where cold air sinks and warm air rises, and this is the movement through a fluid like liquid or gas. Like an ocean or air. And we call these convection currents. And you're going to heat your house with a convection current. So the cold air is going to sink. You're going to find these little swirling arrows on your quiz. Anywhere where you see this kind of arrow going up and an arrow going down is going to be your convection. Okay? The last thing you need to know for your quiz is on insulation and conduction. So I'm going to just draw a line right here. Okay, insulators do not let heat or electricity transfer. So they don't allow heat to pass through. So you're going to insulate your drink so you don't lose heat to ice to the air or cold to the air. So they don't allow heat to transfer. And an example of an insulator is going to be like wood, rubber, air. Those are all insulators. Okay, a conductor allows heat to pass through. It's going to conduct the heat. It's going to allow it to go through. So this allows heat transfer. And your examples are metal is a great example. Okay, so that's going to be all you need. If you can use these notes on your quiz, and good luck.